My name's Jeremy. Also copious free time. And we're going to start by waking up. All right, everybody's here. Joe told us a couple different things yesterday we need to do to get going in the morning. So I'm going to have everybody raise your hands a little bit because I've got some question and answer stuff we're going to do. We got to make sure both your hands work. So raise them both up. Come on. Both of them up. Now clap them. Do it a few more times. Come on. All right. Is everybody getting ready and warmed up? All right. So wake up, everybody. And I got my applause early, so it worked out well. So if you are hoping for the split face with a bald side and a hairy side, unfortunately, I had to take the mean and just kind of average it out. So I'm a bit of a data junkie. I like looking at people's data, see what they have, see what kind of stuff happens, hopefully help them figure out something to do with it or get some really good information out of it. But in general, I'm always looking for interesting data sets, and a lot of the times what we have are streaming data sets or just public data, but most of the really interesting data is people's private corporate data that they're not going to share with anybody, but it helps them do better in their business. So a couple of survey questions. So your hands all work, so I know you can do this. So raise your hand, or both, if you consider yourself someone who processes streaming data. We got a few, all right. Quick examples, anyone? Yeah. Twitter stream. All right, who else processes the Twitter stream? All right, who does not process the Twitter stream? Yes? We process a bunch of Nginx logs. Okay. What's going where? Yes, we have log processing, Twitter stream, all sorts of stuff along those lines. So how many of you say you process batch data? Just 1, 2, 3, 4. All right. So on those of you that process your batch data, how many of you think you process your batches more than once a day? All right. More than once an hour? More than once a minute? Maybe. Anybody process them more than once a second? See, we'll get into the definition of what some people call streaming data, and you'll see a little correlation that's kind of interesting. So this is Big Ruby, so we have to use the term big data. Like Matt, I'm not really a fan of the term. I think it's got a little bit of overhype. But there is a new book out from Nathan Mars. Anyone heard of Storm? Yeah, so there was a company called Backtype, and they developed this whole system called Storm, and then to process the Twitter firehose, and then they got bought by Twitter. So it's actually it's a pretty interesting system. I've only played with it just a little bit, so further experiments are necessary. But Nathan Mars and a co-author of his have a new book out from Manning called Big Data. It's still in beta, so it's only like half there. But it has got some interesting stuff in it. I'll probably mention it a couple times in the talk. But first, we're going to have a little bit of fun with the term big data. So this is Wikipedia's definition of big data. A collection of data sets so large and so complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. I don't know who wrote that. So, and the interesting thing is I did a talk. Who wrote it? Change it? I don't actually change anything on Wikipedia, so I don't have an author bit or however it works. Well, the interesting thing is I did a talk more on the definitions of big data and a few other things about a year and a half ago. And this wasn't the definition a year and a half ago on Wikipedia, so it gets changed, I'm sure. So I have a definition. So for that talk a while ago, I tweeted like, hey, folks, what do you think the term big data actually means? And I got all sorts of interesting comments, some of them from if the data can't be processed in order login time, that was one. When data that doesn't fit in memory. And everybody had all these different definitions. And to me, that kind of boiled down to one basic thing. If you're scared of it, it's big data. I mean, it sounds good because for me, big data, I'm like, oh, something that needs to fit on, a dozen machines. Okay, I know how to deal with that. I'm comfortable with it. So, but something that requires, 50 data centers to deal with, okay, that scares me. Somebody else, something that fits on more than one machine, it might scare them. And so I think anyone's term for big data is the data levels that make you feel uncomfortable. So you can like it, you can take it, do whatever you like. So So this is a model of sort of a big data system, or a data system as you whole. So you have this data. Start off with some data. And you need to store it over here. That's the start. But when you have this data, you realize when you look at it that you actually also need that data. And that's over there, and you need to store it over there. Now here's where the real magic comes in. Because if you have this data, and you've got that data, and you put them together, you get other data. Now, this other data is where the real magic happens, because you're going to use that everywhere. And of course, as in any recipe that requires a couple of ingredients, what's the final one? Profit, remember. So this is well, I'm making a little fun of big data, but this is sort of, in a general scheme, what happens. You get an initial data feed of something. You realize with that something, you need something else to make it complete, or many something else's to make it complete. And you put them two together, and then that ends up being probably somebody's data product, or something that they're willing to give to someone else or use for internal analysis or something like that. So, the term streaming. What do we mean by streaming? So we go back to what the different batch levels. People are doing them 1 minute at a time, 1 second, all those different things. Wikipedia has this definition of streaming data: a sequence of data elements made available over time, and the elements are processed one at a time rather than large batches. Well, there's no definition of large, so what is your data element? A minute's worth of data? A second's worth of data? But if your data element is a summary stuff from upstream that only gets to you once a day, well, it's a sequence of data elements that show up. So for my particular purposes, and sort of the way I kind of think about it, if you're taking data in periodically, consistently and periodically, that's streaming data to me. And they all, because eventually, if you look at that little asymptotic curve, you get down here, and eventually it's infinity. It's all streaming data to one degree or another. So if you also look at it, Jim, your flying robot thing yesterday, you processed the data line by line, those data packets. So technically, Jim's processing streaming data there with his flying robots. So we do have robots processing the data in our world. Just watch out. Let's see. So in my sort of, I came to this sort of interesting conclusion that big data is streaming at the same time. Streaming and big data go hand in hand. Because the easiest way to get a level of data that makes you feel uncomfortable is to have to get it all the time, and deal with it all the time, and deal with all the error cases, and deal with everything that goes with accepting data from someone else, or even your own systems, your own system logs, where you don't know what's going to happen in the log files, and you just got to merge them all together, put them together, and see what happens. So this is just a conjecture, so you can take it for what it's worth, whether you agree with me or not. Up for discussion, so we can chat about it. So the first things first. Now that we've made Josh Susser proud of giving our definitions before we have our discussion, any Rogue fans in here listen to Ruby Rogues? All right, Josh Susser is always saying, well, we start with a definition. So we started with some definitions. Now what's the first thing we need to do in dealing with our data? Anyone? All right, I'll give you a freebie. We need to get the data. It seems simplistic, but this is actually one of the more critical components of dealing with streaming data. You have to get it, and getting the data affects everything down the road. It's basically, you throw a rock in a stream, it's going to affect things down the road a little bit. So, or getting our sequence of data elements. So I've encountered about four different ways of ending up getting data from an external source. And by external, I mean outside of the data system that you're working with. So if you're processing your own Nginx logs, those are coming in, I don't know, maybe over syslog, and then getting aggregated up and then dumped into another system. You've got the Twitter stream that you're pulling on, all these different types of systems. So the first one, and probably quite possibly the oldest, is polling. Who does some sort of polling of data upstream or outside of a system? We've got a few in the back. I sort of like to think of polling as the the data system's way of saying, are we there yet? Are we there yet? Do you have data for me? Do you have data for me? You know, keep on going over and over again, and most of the time the answer is no, yes, no, yes, 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 no, 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 no. So you keep on going, and eventually there'll be some data for you. Now, one of the problems that you encounter with polling is how do you know if you've already received the data before? So there's a couple different ways. I've dealt with retrieving scraped RSS feeds, and the upstream provider gave you a token, basically a timestamp every time you grabbed a chunk of data. So your next request, you would send that, essentially call it an e-tag. You'd say if modified since or something along those lines with your e-tag value, and then they would give you all of the data since that value. So that's one way of doing it. Other places, the upstream doesn't keep track of any location in it, and you just have to pull the data and then check against what you've already received. And then there are some cases where an upstream provider may actually keep your state. So they know. You can just always request, and they'll always just tell you what your next data is because they keep track of your state. I find that one a bit more rare. And most likely the two you see is when you keep track of your own token and you resubmit it back, or you keep your track of your own state in all manners. There are a few problems with polling, and we have the same thing with a couple of the other mechanisms, and I'll try to talk about all the different problems of the different mechanisms of getting our data when we get to, after I do a little review of all of them. So the other one that I kind of like is a notification or webhook type system. How many people subscribe to Rubygems using the webhooks? You do that? So this is a really good example of a notification system. Or PubSub I believe it works this way. I'm not actually sure. Somebody was talking about PubSub the other day. All right. This is a notification system where you're going to say, hey, provider, I want to subscribe to X, or some particular stream, or some particular mechanism of data. And you just say, okay, when you've got data for me, here's how you get a hold of me. And so when something on the upstream provider side, they get data, then they're just going to like ping you and say, hey, you've got data. You need to come talk to me. I've got some data for you. So that makes it pretty easy because you're not actually polling. You're not asking if they have got data. They're just going to tell you when you've got data. And then you go and get it. So the notification actually doesn't contain the data that you're trying to get. It is just the notification that there's data to go pick up. So it's sort of like when the FedEx guy leaves the ticket on your door and says, hey, you've got data you need to come get. Come down to the store before 7 p.m. and pick it up. A third one is it's very similar to notification, but the notification actually contains the data you're supposed to get. So in this case, actually, you may not believe it, but this is probably the one that most people are familiar with this is email. Hey, you've got a new message, and here's all the data that's in it. So, and I would consider email, you processing it periodically, a sequence of data at a period of time. And actually, I have a really fun thing I learned from a couple different people, is one of the best system, like disk queuing storage formats is just MailDir, because every message is in a separate file, and then if you touch it or you read it, then it just moves into the other directory. So using MailDir as sort of a queue processing system is actually a pretty fun thing. It works out really simple, and it doesn't require much code to deal with at all. But it's actually a persistent queue, so that's a pretty fun thing. So payload, again, is essentially notification, but with the data. But it has some of the same problems that notification does, and I'll get to those in just a minute when I talk about all the negatives of all the different methods. And the final one is a push. And the one that everyone knows about for push is Twitter. And how many of us processed Twitter or have processed Twitter in the past? There's a few. Do any of you have, are you just doing the public feed or a 10% feed from, say, GNIP or the actual full Firehose? Anyone? Or are you just pulling it and asking for, I need all the stuff that's subscribed to stuff, subscribed to different people? All right, so this is the big one, push. Twitter's probably the one that almost everybody knows about. This one has different problems than the other two, or the other three, actually. And I've only actually seen it in extremely high volume situations where it may just not be appropriate for anyone to actually store the data anywhere or keep track of a position in a stream or anything along those lines. Or actually Netflix. That's essentially a push stream too. If you were going to process frame data from a movie, you could consider Netflix or Amazon or any other streaming system would be a push system. So in a push system, you basically, hey, open up a socket, probably authenticated in some manner, and then the data just gets thrown at you. So there's a couple of, we'll start with some of the downsides. So we've got these 4 different methods of getting the data. And what are the good things about each one, and what are the bad things about each one? So poll has the bad effect of you have to manage all of your own state. And so you need to know where you are, and you need to know what you've retrieved before, and things along those lines. Notify and payload have a different problem, which is where in polling, you're control of everything. So you as the client are be able to talk to someone and say, hey, I need some more data. Here's where I was last time, or just give me the index. Actually, a really nice one with polling. How many people did a lot of old FTP work back in the day? Anyone use FTP anymore? Well, do you remember in the old archives? You telnet in, or you FTP in, and then one of the top files was ls-lr, was the actual file. And it was a list of every file in the FTP directory. So you didn't actually have to list it. You could just get the ls file, and then you would know everything that was there. So that's actually a really nice thing with polling. You can do the same thing. I've seen it a lot. If you want to go really simplistic with a polling mechanism, just put all the files in a directory and let Apache or Nginx do an automatic index page. So there's the list of all the files that you need to get, and you just get the index, you look at it, and it's like, oh, I have all of these already, and I'll only just get the 2 or 3 that I'm missing. So polling is really good in terms of, it's about the most simplistic one you can do, both on the provider side. So how many of you are actually data providers that provide data to other people? You've got a few? All right. So which method do you use to deliver your data to your customers?
We have a few, but mostly we hunt people.
Yeah, and yeah, that's the thing. That is the beauty of polling. It's really easy to implement almost on both sides. The amount of work you have to do on both sides is simplistic, and it's also extremely asynchronous because as the client, I will just go get it when I have time. But if you are in a situation where you've got data updates that may have a more rapid requirement, it may not work the best based on just the polling. You're like, okay, do I have more data? Do I have more data? Do I have more data? But polling generally seems to be the most simplistic, and it's the easiest for everyone to understand. There's the fewest moving parts. But it does have the negative side of saying, I have to always ask, is there more data? Is there more data? Is there more data? And then you have to deal with how long does the data provider keep their data around? Now, notify and payload are nice in the fact that you don't have to continually ask for more data. You're just told if there's more data. Now, the downside of having to be told when there's more data is that you have to be there and listening, waiting for that message. So if you're not there to receive the message, what do? So both with notify and payload, you actually have to have a persistence set up somewhere that's always available. So your side of the relationship between the data provider and you as the client, or if you're the data provider, you have to keep a list of every single person you need to contact and what their subscriptions are. So on both sides, there's more overhead, and it depends on whether that overhead is worth it in terms of the system and the contract that you and that the 2 parties involved have. Webhooks is a really good one from the Rubygems. And then payload, actually the only one, I haven't really dealt with a lot of ones that actually have all of the data in it. And from my perspective, email is actually probably the biggest one that's here. If you're receiving stuff via email, and there are people that email, hey, let me tell you, it knows how to get data from point A to point B. And it retries for up to a week, all this kind of stuff. So don't discount email in terms of a really good persistent way of sending data to different people, because it works. It's a proven technology. It's been around a very long time. So and there's really good servers that deal with managing data and giving it from a publish-subscribe perspective. Notify seems to be one that a lot of people use, PubSub, Hubbub, webhooks. I think even CouchDB has a built-in sort of subscription that's based on a webhook thing. But don't quote me on that. And then push. So push is probably, at least from my perspective, the most brittle, because you as the client are just going to connect to a data stream, and you're just going to receive data. You basically, that's it. And then you have to deal with it. Most of the time, like for Twitter, it's extremely high volume, so you have to be able to deal with the data volumes that are going to happen. I think it was about a year and a half ago, the Twitter data volume, if you got the fire hose, it was a saturated OC3 line. So how many of you have that network connectivity into your systems? You do, all right, we've got one over here. All right, well, yes, you do, Rackspace, okay, we're good. Rackspace has enough data, has enough bandwidth to actually acquire the entire Twitter fire hose. So push, I think, is when you get to a point where the data volumes are so high that it's actually easier to do this than to keep track of the other stuff. And specifically in a push, if you're not connected to the data stream, you're not getting any data, period. So specifically for, say, Twitter, unless you're paying for GNIP's archival access to all of the old Twitter, then if you miss data, it's gone, and you will never, ever, ever get it again. You know, that's one of the downfalls of a push system. So from my perspective, I'm more on I like to be assured of my data. Then I need to know, and I know that I have all of the data, or I know that all of my customers have the data that they're paying for. So I actually have an ideal way of doing it, and it's a combination. I sort of like the built-in polling mechanism, and I actually think Rubygems does a really good job of doing this, because they have the webhook method where you can subscribe to a certain subset of gems or all of the gems as a whole, so you can just get notified when every gem is published. But because we actually use Rubygems to install stuff, Rubygems by default essentially has a top level, you call it anyone looked at the Marshall file that holds the list of every single gems in Rubygems? You know, it gets built every single time a Rubygem is published. It's great, and it actually has the list of every single Rubygem in the entire system. So you have the list of everything. So not only do you have the benefits of webhook, where you don't have to poll all the time, but you have a backup mechanism to get all of the data. Say your webhook listener was down for a week. You missed a week's worth of data, or just a day. Well, you can say, oh, well, I missed all this. Let me just go get the top-level index. It will list all of the gems. I can ingest it. I can go through it and say, well, I've got these 80,000, and I'm only missing the 4,000 from yesterday, or 2,000, or whatever the rate these days is. It's getting pretty fast. I know we're publishing a lot of gems these days. So for my ideal, either a webhook mechanism that gives you a notification, but with a fallback of being able to say, of polling, or something along that use eTag that allows you to say, okay, give me all the data since this amount of time, but the upstream provider needs to be able to provide a mechanism for any depth. So it's basically, hey, I need all the data that you would have given me since last Tuesday. So those are the two biggest ones for me. And if you don't have a callback mechanism, I'm happy with straight polling, because it's so simple that everyone can do it. Everybody is more comfortable in a polling situation, at least from my perspective. Other people may have a different opinion, but from my perspective, polling works out the best just from both the data provider and the data consumers, because it's just the most simplest mechanism possible. And I'm a big fan of the simplest way that works. So I use cron and maildir to get stuff done. And it works out great. Or actually, I'm probably going to do a lot with systemd in the future, because it started sort of has anyone done a lot of work with systemd? Linux side? Okay, I might want to chat with you guys later. A lot of people do like the push, but again, I'm not a fan because I think it's more brittle, but I do believe it's there, it's needed, it's there as a good, when you reach a certain data volume level. So when I was working on this talk, I thought there was actually going to be more code involved, and I realized that the fundamental concepts that we're talking about might be a better introduction of where everybody's going, and keeping your head above water by understanding the ecosystem. I was trying to deal with a public data stream that wasn't Twitter. I've dealt with Twitter too much. I think it's an edge case in terms of data streams. I mean, everybody wants it, but in terms of the possibilities of data acquisition from other locations, it's an outlier in terms of how you get the data. So I was looking for a good data source. Is Win here? Somewhere, I don't see his hand. So GitHub Events. The new GitHub version 3 API has an event stream. If you just go to api.github.com/events, you're going to get basically a JSON dump of the last 30 events that happened at GitHub. And then it's got this really nice links header for you giving you the next and the previous, and you go up to 10 pages back. But it does a nice e-tag mechanism. So you can say, okay, give me the events. It'll send you an e-tag header. You do an if modified, and it'll give you the next set. And then you can page backwards in time and get the data that you've missed. Now, the bad part is it is a polling mechanism, but their events are getting published, one a second or something like that. So polling is going to work. You're pretty much always guaranteed to get data. But there are some interesting stuff. When you're polling different people, you have to deal with their, or use the data provider. You are giving out your terms of service. So for GitHub, for instance, they have a couple of headers. I think it's xpoll interval, which says how often you're allowed to poll me and ask if there's new data. And it's 60 seconds right now. And then the other one is sort of a rate limit from your API perspective, like how many requests to the API you're allowed to make per hour. So you as a data provider or you as the data consumer need to work around and make sure that everyone can get the data they need within the constraints provided by your API. And GitHub actually provides an interesting backup mechanism. So for me, I always like to be able to poll. And then if I'm missing or I'm not there to poll, something's down, I like a backup mechanism to get the data. Well, it's not me, but has anyone looked at GitHub Archive yet? So Ilya Grigorik, he has been scraping GitHub. GitHub has another endpoint called timeline.json, which gives you the events, but in a slightly different robustness. There's more data in those than there is in the standard events API. It should be the same events, but there's a little bit more, so I'll call it sidecar data is there. But he's been scraping it since February of 2011, I believe. And so all of it's available online. And he's got it in big tarballs of JSON gzip files, 1 per hour. So if and he's polling separately on a different network, actually at Google, I think. So when I poll for the GitHub events, I do have the knowledge that, hey, the GitHub archive is also scraping a different part of GitHub and getting the same data. So if I fail, then I know I could fall back and go get his data and fill up the holes that I have, which is pretty cool. So in this case, I like the mechanism, being able to get the same. This provides an example of basically being able to get the data in multiple ways. And I think that's really important, specifically for a data consistency perspective. And the ability, there's GitHub Archive. And the ability to say, I know I've received all the data that was actually available. So we've completed step 1, get the data. So we're not going to go through all of the this, that, and the other. Maybe I'll do some more talks and develop a little series or something like that. But we're just going to go over the first 2. So now we have this data, and now we need to store this data. One of the things that a lot of people are interested in is, okay, how much processing should I do on the data before I actually put it on disk? And there's a data quality level where you say, I want to introduce the least amount of change possible because I might screw something up that I don't know about. So from my perspective and a few other folks, and actually the big data book also mentions this too, you want to do as little data processing of the original input stream as possible. You may have the cases, once you have the data, you can do whatever you need to with it, but making sure you have it is very important. Because if you don't have it, you can't use it. So making sure you have it and it's on disk and you can access it at will is probably one of the most important pieces of this entire system, or any type of data. So I'm playing with the GitHub Event API, and the data you get is just a JSON stream, or a JSON chunk of array of events. So all I'm doing in it is splitting that big array up into individual JSON hashes, and then sending it to the piece of my program that's actually going to store it to disk. So in this way, I'm doing the minimal amount of processing, because if I actually did some amount of processing with it, and I don't save as much of the original as possible, I've changed something, and this is a case where you sort of can't roll back unless you go and retrieve the data again, and that may not be available. So where do you store it? I consider this is the raw fundamental truth data of your system. So making sure it's available all the time and backed up and all of the wonderful things we need to do. I don't really care where it happens. Maybe you're using, you've got anybody use NetApps, Isilon, Hadoop? Anyone on any of those things? Yeah? Anywhere where you essentially have redundant fault-tolerant storage. That's the big piece that I think is really important. When you get this initial data stream, just making sure it's completely available and is available for later processing. And Hadoop is probably one of the, of the three I mentioned, it's probably the cheapest by far. And it provides you fault-tolerant redundant file system that's distributed and can grow linearly with the amount of data you're going to acquire. And it's also amenable for later processing if you're going to do HBase, just straight up MapReduce, for just we caught the other one, something like Pig, Cascalog, any of these other things that are wrappers around MapReduce, they're all going to work with this. And so just being able to store your data as the raw data as it's coming in into a nice system is a good starting point for later processing. And specifically, if you want an actual file format to store stuff in, I'm a fan of Avro. How many people have heard of Avro? All right, how many people have heard of Message Pack? Oh yeah, Thrift. Okay, these are all other sort of serialization mechanisms. Avro is another one. I actually particularly like Avro file formats because of all the ones that are these serialization mechanisms. I think it's the only one that actually has a file standard. All the others are, if you want to just call it, record levels. So the Avro files actually have the schema is built into the file system, or built into the file, so you actually don't need like the special headers that say, record A is this, record B is this. And it also works very well with MapReduce, and it also has built-in small sub-chunks in the file for checksumming. So if you do happen to have a catastrophic corruption of certain amounts of your system, Avro files are correcting enough so that you only lose the piece that's corrupted. You don't say lose everything after it. Standard text file, if you have a corruption at one point, you basically lost everything from that point to the end of the file. With Avro, if a file gets corrupted, some bits get screwed up, you can basically isolate it to a chunk of the file and skip it and move on. So I think it's a really good format in general for doing any sort of record type of stuff. So why do we go to all this trouble? We're just getting the data and putting it on disk. And we really haven't even looked at it yet. We haven't done any analysis on it yet. We haven't, while we're doing this, we're probably getting counts. We're seeing how fast we're getting it and maybe byte sizes and different things like that because we need to know that data. And it's because this data we're acquiring is the fundamental truth of the rest of the system. Any alteration we do of it before we actually start processing introduces either a flaw, a mistake. You might think you're doing the right thing, but if you screw something up at this point, you've affected the entire rest of the system. So being able to have this raw upstream data archived for essentially as long as is necessary to keep it, you can fall back to it. So if you're taking some of this processing a little bit and then throwing it away, then you can never go back. If that processing had a mistake in it, and that's one of the biggest things you have to deal with in a big data or streaming system is human error. we're going to make a mistake. And I'll guarantee you're going to make a mistake. 2 weeks later, you realize, oh my gosh, that processing we did on 2-week-old data, yeah, we were wrong. We did the calculation wrong. We need to redo them all. So to be able to redo them all, you have to roll back to where it came from. And you don't know what you're going to find out next. Depending on the archive level of your data, do you need to keep it for a year? Do you need to keep it for 2 years? Say you come up with a new algorithm that you're looking at on your data with, and you realize, you know what, it would be really good to look at how this has progressed over time since the beginning of our data stream. So going back to the beginning and being able to process that algorithm again through the entire system allows for future discovery. So you don't know what you're going to use it for in the future. And there's actually a good quote, and I might have from the Big Data book is, nearly every large data set has unanticipated value within it. And ultimately, you can't discover interesting things with your data unless you can ask arbitrary questions of it. Which I think it sounds pretty good. And it's sort of, from my perspective, the follow-on conclusion to that is you cannot ask interesting things of data that you don't have. Logical conclusion to me. So paranoia. It sounds like I'm paranoid about this, but I am, because if you make a mistake here, a lot of the times you can't recover from it. The only way to recover from a mistake here is if your upstream data provider allows you to go get the data again, which is why I always like to have that mechanism available, because I'm going to make a mistake in here while I'm developing the system or something like that. So being able to roll back to a known point. But your upstream data provider may only be keeping the data for 1 month, or 2 months or something like that. So whatever that relationship is. So from my perspective, the monitoring, the development, this is an area where it pays off to be extra paranoid. Yeah, so for instance, processing the Twitter feed. I used to work at a company called Collective Intellect. We processed a 10% Twitter fire hose. If our collector went down for a minute or 2 minutes, that data is gone. You're never going to get it again. Although it is Twitter, so 99% of it is junk, so it doesn't really matter. So the probability that you're actually going to miss that really important mega tweet is low, but sometimes your customers don't understand that. Or say your collector was down for an hour. Something happened. You lost your primary and failover, or your data center had an issue and there was a fire. Sometimes these things happen. We had the fans go out in our data center once, and all of the machines sent their CPU core temperature alerts off, and we had to crash the system. And while that was done, we didn't collect data. So when we brought up the system the next day, after the fans were done, the air conditioner was back on, we lost essentially a period of data that we will never be able to get back again. Your customers are paying for analysis of data. There's a hole. They don't understand that. They're like, I paid for that. So making sure that you're paranoid in this and having primary and secondary and tertiary acquisition methods for your data, I think is one of the most fundamental things that's required for dealing with your streaming data or just any data in general. I don't think we have time to look at the code, but it's on copiousfreetime/Gent, G-H-E-N-T, on GitHub, and that's me. I can take a couple of quick questions, or I have a quick bonus track if you want. All right, sounds like we want a bonus track. I got a minute and a half, so here we go. So while I was doing this, I was reading this big data book, and a lot of the stuff that was happening in it, and it's not even all the way written yet, so this is just like the first third or half. And I was like, wait a second, all these things sound really familiar. Where have I read this stuff before? So this is sort of the what if. Everybody read XKCD? You know the what if numbers? He's got his what if session. It's like, these are the interesting things I've discovered along the lines as I've been working on these what if things. This is my what if track. So on the left, we have the quote I just read from 2013. And on the right, we have, it's a bit more verbiage. But to me, the biggest one is this one right here, the one on the far right. But perhaps the largest benefit of the Data Warehouse Foundation is that future unknown requirements can be accommodated. Wow, that sounds a lot like this, doesn't it? And that's from 2002. Or this is the term from a real-time ETL. refers to software that moves data asynchronously within a data warehouse with some urgency. So, you know, data's coming at you pretty fast. This is called the Data Warehouse ETL Toolkit from Ralph Kimball in 2004. So what is old is new again. This is really interesting that basically what we're calling, and this is my conjecture, is that what we're calling big data is actually what we've been calling data warehousing and ETL for a long time. So I'll leave you with that thought. Enjoy.